Hi friends, I'm Lasya. Today I'm here to do the seminar on the chapter rational numbers. So these are the learning objectives of the rational numbers. What is a rational number? Properties of rational numbers. How to convert rational numbers into different types. So first let us see what is a rational number. Here is the definition of rational numbers. The numbers which are expressed in the P by Q form where P and Q are integers and Q is not equal to 0 or called rational numbers. This is the main condition of rational numbers. So now let us see some examples. 2 by 6 minus 5 by 8 minus 7 0. Friends, is 0 a rational number? Yes, of course 0 is a rational number. Let me explain you how 0 is a rational number. We can represent 0 as 0 by 1. In this condition, q should not be equals to 0. Whereas when comes to p, it may be 0 or any other integer. Now, in this example, 0 is in the numerator. So, this can be a rational number. And 6 is also a rational number. Now, we'll go under properties. We have four properties. Closure property, commutative property, associative property, and distributive property. These are all the general forms of this property. Now we will go properties into rational numbers. Closure property is closed under addition and subtraction. Commutative property is also closed under addition and subtraction. Associative property is closed under addition and but not satisfied under subtraction. Distributive property is closed under addition as well as in subtraction. Now let us go into multiplications and divisions. Closure property is satisfied under multiplication and division. In division, except 0, it is satisfied in all the numbers. In commutative property, it is satisfied in multiplication and but not satisfied in division. In associative property, it is satisfied in multiplication but not in division. In distributive property, it does not satisfy in any condition, neither multiplication nor division. Now, representation of rational numbers on number line. Example, 8 by 7. Here, 8 by 7 is a fractional form. So, first we have to represent it in a mixed fraction. So, after doing the mixed fraction, we'll get 1 by 7 as a mixed fraction. The whole part is 1. So, the fraction 8 by 7 lies between 1 and 2. So, we have to divide 7 parts because the denominator is 7. So we have to divide 7 parts between 1 and 2. As the numerator is 1, we have to pick the first part. The first part is 8 by 7. In the same way, we have to represent the rational numbers on the number line. Representation of rational numbers between irrational numbers. Examples. Here is an example or a question. Find a rational number between 16, 6 and 17. This is the formula to insert a rational number, a plus b by 2. According to the problem, a plus b or a and b are 6 and 17. So 6 plus 17 is equals to 23. 23 by 2 is the rational number between 6 and 17. Decimal representation of rational numbers. For example, 17 by 5. This is the easy topic. We have to do just normal division. After doing the normal division, the quotient is 3.4. So the decimal form of 3 by 4. Representing non-terminating recurring decimals. For example, 5 by 3
Sir, sorry, sir.
the normal division. 5 by 3 is equals to 1.666. We may represent this as 1.6. So it can be written as 1.6 bar. Conversion of decimal form into rational form. Now let us first take the terminating decimals. For example, 15.75 is the terminating decimal. We have two numbers in the decimal part. So we have to multiply it with 100. If we have three numbers, we have to multiply it with 100. So in this question, we have two numbers, so that we have to multiply it with 100. So we have to multiply with this 100. After multiplying the number, we have to reduce it into the simplest form. After doing all that, we get the answer 63 by 4. So 63 by 4 is the rational form of 15.75. Converting a non-terminating recurring decimal into a rational form. For example, 0.4 recurring is our example. 1x is equals to 0.4 recurring is the equation 1. In this question, one number is repeating. So the periodicity is 1. So we should multiply it with 10. If the periodicity is 2, we have to multiply with 100. So 10x is equals to 4.4 recurring is the equation 2. Now we should subtract equation 2 from equation 1. 10x is equals to 4.4 recurring minus 1x is equals to 0.4 recurring. 9x is equals to 4. So x is equals to 9 by 4. Hence 0.4 bar is equals to 9.4. Thank you, sir, for giving me this golden opportunity to improve my skills. Thank you, everyone.